So up until now, we've run commands on the command line, docker run and a bunch of arguments, and that's been per container. Now imagine you've got like a big microservice architecture, or even not that big, just 3 services or something. You don't really want to do that every time you spin up your architecture. You want this stuff source control so that other team members can spin up the stuff as well. You don't have to remember each time. Now obviously you could do like a PowerShell or a bash script which had docker run this, docker run that. But Docker Compose files make this so much easier, and also add a whole bunch of other stuff on top. If you're following along and you've got the source code that comes with this course, then grab the latest version for this module and run this command, docker compose up -- build. And we can see that very quickly we've got a working copy of our website with the API, with the front end and the database seeded by literally just grabbing the code and running docker compose up -- build. That's really powerful. So now let's dig into how we've achieved that. So this is the Docker Compose YAML file, and this is how we solve the problem I described in the last section, where rather than typing docker run lots of command line arguments, we can have it in a YAML file because we all love YAML files. And you can see straight away that a lot of it should look quite familiar from when we did docker run. So we've got the port numbers for -p, remember that? We've got an image name, we've got the container name, and we've got one of these, a YAML block for each of our services, so the front end, the API, the database. And even like the database has environment variables, so that will look familiar because we specified those on the command line. The port numbers, just like on the command line, to the left of the colon, that's how we're going to access it. To the right of the colon, that's what the container is internally listening on, so Nginx listens on port 80, for example. On line 13, you can see the port number I've specified, 17,860. So if you remember, if I go back to the front end and we go to index.razor, do you remember I specified that when I span up the API, it gave it that port, so I just used that when in the front end. Obviously, you wouldn't do this in real life. You'd have configuration. I've done a lot of .NET already in this, and it's not a course about .NET, so I didn't want to delve into .NET configuration, so I've hard-coded it. Don't do this in real life. Obviously, this will go through some kind of configuration, but for now, I've just hard-coded this port number. But note that I put the same port number for the API in Docker Compose, so that's how we're going to expose the API. Another thing to point out is that remember that this is a SPA application running in the browser, so this REST request is not container to container, it's browser to container, browser to the API. And then in the next section, we're going to look into how to actually run this Docker Compose YAML file. So to run this Docker Compose YAML file, we go back to the command line, and there's another command that we've not used yet called docker compose. If I run this without any arguments, then we get a whole bunch of commands, which a lot of these will look quite familiar. Things like run, ps, logs, exec. So a lot of these commands where you would have done it with just against one image or container, you can now do it against everything in your Docker Compose file, which again is source controlled. The main command we're going to use is a command called docker compose up. And what this does is it spins up all the services in your Docker Compose file. So if we run this now, and note that you run this in the same directory as your Docker Compose file. And we can see now that this has just spanned them all up. Now this is scrolled by quite quickly, so I'm going to scroll back up again. And we can see that at the top, it creates a network, and we can talk about networks later, but it also creates each of our 3 containers. It then attaches to those containers and dumps out the logs. If we scroll down a bit, we can see we've got different colors for the different logs. So front end's green, database is yellow, API is blue. So this just makes it a lot easier to work out what is coming from what container. If we Control-C now, then we can see that it's stopping those containers. Note that it's not deleting the containers, it's just stopping them. And another example showing how similar this is to the commands we've already looked at, -d for detached, we can do that here. So this is going to start the containers, and then we get the command line back. We can do other commands like docker compose ps, which we've already seen. So that's listing all the containers in this Docker Compose. Note again that this is looking for the Docker Compose YAML in the current directory. We can also do docker ps to show all containers running on this system, and obviously that includes the containers created by the Docker Compose as well. But it's possible that docker ps would have a lot more entries than docker compose ps. Another example, docker compose logs, because we've got this running now, our containers, we can just dump out the logs for all of those containers. We can also do Docker Compose logs and an explicit service name. The service name comes from the YAML file, and that's just dumped out the logs from that service name. If we do Docker Compose up again, then that's reattaching to it. So it's already running, so it's not said created, it's just said it's already running, but it's attached back to it. So if we get any logs now, we'll see it because it's attached to this terminal. And then Control-C again stops those containers. If I do Docker Compose down, so we've done up to spin it up, if I do down, that'll spin it back down. And this is different than Control-C because this deletes the containers as well. So we can see it's removed the containers and it's removed the network. So this is kind of really good if you just want to tear everything down and start again. Your database might have changes made. If I do this and then spin it back up again, I've got a fresh database. So it's a great way of just starting again. Note that at this stage, our website won't work yet because remember that we hard-coded the connection string on the API to localhost. And remember before when we spun this up in Docker, without Docker Compose, it didn't work because it was accessing the database on localhost. And obviously localhost for the API is inside that container, so there is no database inside that container. We'll address that in the next section. So how do we fix this issue where the API needs to talk to the database? One great thing about this Docker Compose file is that each of the service names, so front-end, API, and database, act as DNS entries. So you can put whatever you want in here, but that becomes the DNS entry. So if we go back to our code now, and instead of localhost here, if we change this to database, so that matches the database Docker Compose entry. And that's it. It's as simple as that. For one container to access another container, as long as they're both spun up via the same Docker Compose, then it can just use the Docker Compose service name as the DNS entry. In the last section, I made a change to some code. Now I could go back to the command line and do docker build and build the API image again. But wouldn't it be nice if it didn't have to? And you can do that in the Docker Compose file. So if we make a change here, if I go to the front end and do build, so I'm adding a new YAML block called build, and I'm adding context. Do you remember from the command line, if I did docker build dot, that dot was the context, which was a directory, then we just enter that here. Now note that this is relative to the Docker Compose YAML file. And actually, if we look at the path, this is the front end. So the path we want here is, this is where the Docker file lives. So we need to specify that relative path. So this will be Docker course front end and Docker course front end again. Now, because the Docker file is in the same folder, that's fine. That's all we need to do. For the API, do you remember the Docker file is in a different folder than we had to specify for the Docker context? So with the API, again, build, the context was Docker course API. In fact, it was that one because it was the directory before the Docker file. Now here we also have to specify the Docker file, and this is relative to the context. So in this case, it will be Docker course API Docker file, which if we look in the Explorer, we can see that it's relative to here. So it's just Docker course API Docker file. So going back to the command line, we can either do Docker Compose build, which will build all of those images where we explicitly say the Docker file in our Docker Compose file. And that's worked. We can see that it's built multiple images. Obviously, they're all cached from last time we did it, so it was super fast. Or another option is we can do Docker Compose up, because we want to spin up all our images, and do -- build. That will make sure that they're built beforehand. And again, it's built them, and now it's running them all. So because it's built them, this will have built the change we made, where we changed the connection string to database instead of localhost. So the last piece of the puzzle is we need to seed our database with some data, because SQL Server, when we spun it up, hasn't even got our database, let alone the seeded data, the list of podcasts. So if you remember earlier on in the course, we manually ran these commands, the create database, create table, insert the podcast, the values into the table. Now we can do that again manually, but it'd be nice if we didn't have to. And if you look at the latest version of the code that you get with this course, then you'll see there's a database folder. And in this version of the Docker Compose file, there's a new service, database seed. Now you'll see that it says depends on, so this is a new argument we've not seen before. So this basically says this service depends on another service. So it's going to wait for that other service to spin up successfully before this one will spin up. So you can see here that we're following the same pattern as the API in the front end by specifying a Docker file. So this is a new Docker file, which would be built when we do docker compose build or docker compose up -- build. If we look at that Docker file now, we can see that it's quite simple. The from command says that this image is going to be derived from SQL Server. Now we're doing this because this image has the command line tools we want to do to run SQL commands. And we've already got this exact same image cached from, because we are spinning up SQL Server anyway. So we've already downloading it anyway, so we may as well use it. The next two commands are the copies. So they're copying the SQL command into the container, and it's also copying a bash script, which we'll look at in a sec. Now the last command, cmd, this is very similar to entry point. I'll have a section later on in this course where I'm going to dive in a bit deeper into the difference between cmd and entry point. But for now, see it as the same thing. This is the command that will run when our container runs. And this is pointing to this bash script. So if we look at this now, then this looks more complicated than it is. First of all, we've got a for loop. And whilst we saw the depends on in the docker compose file, that's quite raw. That's just saying, has the other container successfully started? But we actually need to wait for SQL Server to be initialized properly. So that's what this for loop does. We can see that we've got a command in the loop, which basically runs SQL command and waits for a successful response. If it doesn't have a successful response, it's just going to echo not ready yet and try again. If it does, then it's going to exit out of the for loop. When it exits out, it's then going to call SQL command again, but passing in our create database and seed script, which is going to run our script, which is going to create the database. It's going to create the database table, and it's going to seed the list of podcasts into that database. So now if we do docker compose again, docker compose up build, it's going to build them again. It's going to spin them up. If we just wait a second, then we should be able to see, let's scroll up a little bit. Not ready yet. So you can see this polling to make sure it's ready. And SQL Server is ready. And then if we scroll down a bit more, we can see that the database script has run here. So hopefully this means that if we open up the browser and go to localhost 1234 and click on Get Podcasts, we have successfully got our podcast. Now we've got the database, API and front end all running in Docker now, and we're spanning it up with one command. You can see that this says localhost 1234. If we go back to the docker compose file, you can see that I've specified 1234 here. So that's where that's coming from. That's the port that we can access the front end on. And we are now at the stage where if you were following along in the first section of this module and you got the source code and you just ran docker compose up -- build and you saw it working, that's the stage we are now. Now, imagine you're a new developer working for a company. You come in, you make sure that your machine has got Docker Desktop installed. You git clone the source code and you just run docker compose up -- build and it spins up. Imagine the code base has lots of different APIs. It's got a database, it's got a few different things, maybe RabbitMQ, and it just spins them all up and you can run it within minutes on your machine. How powerful is that?